All right, guys, we're gonna get started here. It's a big room, and it's a panel, meaning it's Q&A, and you guys asking questions. So I might encourage you, if you're in the way back, to just try to fill in towards the front. It'll be easier to hear you or get to you with a microphone. So I'm Jason McGee. I run Cloud Platform for IBM Cloud. This session is a panel discussion around service mesh and microservices and the projects associated with it. What we'll do to kick off is just ask everyone to introduce themselves and what you do, where you're from, and what's your relationship to service mesh, and we'll go from there.
Okay. I'm Louis Ryan. I'm an engineer working on Istio for Google. Been working on that since the project started, and that's what I do for my day job.
Hi, I'm Tamar. I'm an IBM fellow working in IBM Research, and I'm working with the IBM Istio team.
Hi, I'm William Morgan. I'm one of the creators of the Linkerd project, which is a CNCF service mesh, and I'm also the founder of a company called Buoyant that does a lot of the work on Linkerd.
I didn't get one. Hey, I'm Zach Butcher. I was one of the early engineers on Istio at Google and left about 7 months ago to help start Tetrate, which is a company that's building products on and around Envoy and Istio.
Great. So let me just poll the audience. How many of you are kind of novices to the concept of service mesh? Oh, that's easy.
Awesome.
Everybody. So maybe we'll start somewhere really simple. And what I'll do is I'll just try to get us started and then be thinking of questions, because we'll be out in 5 minutes. So why don't we start with, what problem is service mesh trying to solve? What is the core use case behind service mesh? Anyone?
I think, William, you should get to go first.
Uh-oh. A service mesh is a magical creature that solves all of your problems.
Like any good new project, does everything.
Like any open source project, or your money back.
Right.
No, so I would say a service mesh is a layer of infrastructure that's designed to give you kind of a global layer of visibility, reliability, and security across your entire application or across your entire cluster without involving a whole, and ideally without involving any changes to the application.
Right.
Yeah, so I think that's something that we would all generally echo, right? It's a networking of abstraction, a higher level networking layer that works with your orchestration systems. It can observe services, their endpoints, can help operators control the flow of traffic, APIs, microservices calls between those services, and it operates at that layer and provides abstractions to do things around telemetry, security, policy management, et cetera.
So when we talk about service meshes, there's often kind of three, core scenarios we talk a lot about: observability, control, and security. And I think maybe one of the challenges with service mesh right now is, where do you start? So any thoughts from the panel about kind of which of those scenarios or entry points are the common place for people to start? Go.
So I think that
first one
what
to the
we're
mic
seeing
wins.
From the sponsored users that we're working with, so one place that they want to start is the visibility, because they actually have no idea what's the latency between their microservices and who communicates with who. So visibility, in order to gain some insight about what's going on and do some troubleshooting, is one place where we see that people want to start.
Agreed.
Yeah, I mean, we see kind of which vertical you pick that aligns fairly well with kind of what your company prioritizes always. So you go talk to financial people, and typically they're going to pick security first.
Right.
You go talk to most of the world trying to do microservices, and it's all about observability, because nobody knows what the heck is going on in the cluster. And traffic management tends to be tends to follow a little bit in our experience, right? So it tends to not be as pressing a concern, because we have things like middle load balancers and other things like that we can use to kind of get by, that we're used to using. But that at least has been our experience talking with the people.
Great. So on the panel, we have kind of two major service mesh projects represented. Maybe we could just take a minute and maybe you could start, William, and just give a quick kind of state of Linkerd, and we can do the same thing with Istio and just give people a sense for where those projects are at.
I'm outnumbered.
You are. It's true.
So state of Linkerd, let's see. So it's been around for a couple of years, actually. I think we were the fifth CNCF project accepted to the CNCF. Right now, there's kind of two versions which are quite different that are both kind of currently in production at various points. There's a 1.x stack, which is built primarily on the Twitter stack, so things like Finagle and Netty and Scala and the JVM, very widely deployed, often in kind of the enterprise world, who's very familiar with the JVM. And then we have the 2.x versions, which have been mostly what we've been demoing and showing off at KubeCon, which is a rewrite with a custom proxy written in Rust, which is very fast and very small, and a control plane that's written in Go. And it's a community project. We've got a lot of contributions and a lot of people adopting it and playing around with it and getting involved. And yeah, it's ready for you to try.
And I also want to say one of the cool things that I continually see come out of Linkerd and out of Buoyant is like awesome tooling for debugging and things like that, which is super cool to see.
Louis, you want to?
Yeah, sure. So we had our 1.0 release last summer, and we've been kind of chugging away, doing point releases, dealing mostly with making sure that the system is production ready for use, so making sure it scales up to whoever wants to use it, fixing bugs, etc. The next release that's coming up in 1.1, which hopefully will be in January timeframe, slightly later than we hoped, but this is software, that happens. We're doing some architectural things to make it easier to scale up Istio, to make it easier to use in multi-cluster environments, to make it easier to configure, and in particular, to make it applicable in environments, or easier to use in environments other than Kubernetes. So there's a couple of major architectural things that are going into that release, and you'll see us start to build on those in the point releases coming out through next year.
Great. Anything else? All right, one more for me, that's your turn. So both projects that we just talked about, while service mesh is new, and obviously for you in the audience, many people are just learning about service mesh, the projects themselves are actually multiple years of work already. Are there inhibitors that we think exist that are preventing people from getting started with service mesh, or is it just a new concept, maturity, learning curve problem?
They haven't heard about it yet.
Yeah, that could.
It's too obscure.
Okay. So it's just learning. It's just what the heck is a service mesh? Once you guys all hear about it, they're instantly going to deploy it and start using it, no problem.
So I think I have some of the hindsight, having been in the service mesh world for a couple of years. Early on, it was very much here's this new thing, and here's what it does, and here's why you need to care about it. And no one really wanted to have, no one wants to have that conversation. You've already got 50 things that you're thinking about. You don't want to have to learn about a new thing. Over the past few years, I think that's completely shifted, and now everyone at least is aware that the service mesh is a thing. Now, you might not know what it does, but you know that it exists, and it's like an object in the universe that you can start thinking about. That's been a huge change. So I think now it's less about like, am I aware of it, and more about, okay, does it have a value prop that makes sense to me, and can I actually adopt it given the specifics of my infrastructure?
Great.
In kind of a more Istio-specific case, I think maybe one of the biggest blunders that we made with the project starting out is releasing it as this big monolithic thing, and that has certainly been a barrier to adoption for Istio specifically. And to Louis' point, right, in 1.1 and moving forward, we're making large efforts to try and address that and make it consumable piecemeal.
Yeah, it does many things, so
yes.
maybe separating the things it does.
Exactly.
Right.
So I agree that it's a maturity thing. That's one thing, and I think the other thing that I want to add is complexity. So at least there is a perception that it's complicated, and I think we need to do more in terms of the user experience, and things such as debugging tools can definitely help.
we learned a lot about that with Linkerd 1.x, which was very much, very widely deployed, but there's a lot of friction to adopting it because it was this big complicated piece of machinery that you had to wrap your head around, and it had this configuration language that you had to learn, and it was very much presented as like, hey, you just learned Kubernetes, which has 1 million APIs, now here's like another thing that's super hard to understand to layer on top. And so people who adopted it, they got to the value prop, but it was kind of at a cost. And so with the 2.x rewrite, we've been taking kind of a very sharp knife onto that and trying to make it as easy as possible to install and to make it feel not like it's this giant thing that's going to require 6 architects in a 5-year plan, but instead like it can be a tactical decision. Like let's just install it in a single namespace. Or let's just mesh one service. Let's just get comfortable with this thing and make it a tactical decision, not a huge strategic decision. There's a bunch of other like cool engineering stuff we've done that I'm not talking about at all. But the shape of the project has changed in response to a lot of the pain that we've seen Linkerd 1.x users have to go through to get to the value prop.
Yeah, so I think there's like most of these projects, there's a stark difference between infrastructure and usability that sometimes any open source project is going to struggle with.
Yep. I
think the other probably big thing is service meshes represent a change in security posture, right? In the way that we're asking enterprises to think about security in a slightly different way that they've been used to thinking about them with network segmentation and all the things they've been doing with micro firewalls and things like that, and asking people to kind of internalize this kind of workload identity model and what that means for their security posture. That's not an overnight conversation, right? That's a very, very long conversation, internal at organizations. What does this mean for my operations, right? That does not change overnight. So that's another thing that's going to kind of over time, as people understand the benefits of those things, then hopefully they provide real benefits to them, right? We have to prove value prop. I think that's another thing that is just a naturally slow adopter, particularly that domain.
Yeah.
We just call it magical security sprinkles, and everyone just does it.
Right. They adopt that stuff right away. All right. How about you guys? I have questions from you. Yeah. Abstract the Envoy part of Istio.
For instance, they were going to collect one-to-one relation between Istio objects and configuration of Envoy.
All right, let me repeat the question just for everyone else. So the question is, do we have plans specifically in the Istio project to abstract just the Envoy plane or have a representation in the control plane just for the Envoy part of the stack? Is that fair?
So I guess the question is, abstract it to do what precisely?
I will not be able to push Envoys in the configuration. I have to go always through Istio.
Oh, okay, yeah. Okay, so our
configuration of Envoy in such a way, if Envoy does A, I have to wait for Istio guy to support A.
Yeah. So how do I configure the Envoy with the new features as it's being shipped and Istio lags behind? That about summarizes. Yeah. So fortunately, you're right. Like we try to kind of abstract the Envoy model away a little bit, but there is a break class there. So it's called the Envoy filter CRD. You can push that, and it's basically a break class. Insert this Envoy config right here in the chain. And that's the backstop to be able to use new things in Envoy, custom filters that Istio doesn't represent, that kind of thing.
Yeah, so I think the general goal is to more or less keep pace with Envoy, right? We haven't quite been able to do that because we've been doing some major architectural things and some structural things in the API. Because what Istio really does is it takes a bunch of different things, right, and it assembles them into configs for each individual Envoy, right? And each of those resources that we're assembling from has different ownership, right? Whether it's by namespace, it's controlled by an admin, right? So the job of Pilot is to assemble those things. When that piece becomes more stable and more baked in and more more user-friendly, then it's much easier to keep pace with the kind of just raw Envoy features, right? Because there isn't, on a feature-by-feature basis, as long as the right abstraction or the point of ownership in the domain is defined, then it's pretty easy to just keep incrementally adding things. But we do have break glass, and there are actually other we've seen other companies do some things around kind of layering on top other break glass solutions too.
Great. I'm going to go here. I'm just going to bring the mic to you. If you're in the back, you're going to have to scream or come up here.
So, to your earlier point about initially how we look at service mesh, what is the definition of service mesh? One of the things is when we hear about service mesh in context of Kubernetes, container management, microservices. But those microservices applications need to talk to some legacy applications, legacy database sources. So we then start thinking about API gateway. So how do you guys see where does service mesh? What is the boundary? Where does API gateway comes in? It'll be interesting to see your perspective.
You want me to take a crack at that one?
You own an API gateway company, in
I've
addition
done
to
some
other
API
things, I
gateway
think.
stuff. The boundary is pretty subtle, right? I mean, what's the difference between an API gateway and a proxy configured to route traffic to n different things, right?
Yeah.
So it's a very subtle distinction. What we're
And I'll
looking
point
at.
out, as you get bigger, the distinction becomes less clear as well, because different parts of your organization are really not effectively different than people that are outside of the organization. So it's a blurry line, right?
Yeah. So probably the first thing I'd say is service mesh is not just for microservices. Service mesh is not just for Kubernetes, right? We're actually working quite hard to make sure that service mesh works for VMs.
Yep.
Service mesh works for giant mainframes, I guess. You guys make some of those.
Sure, we make some of those.
And really, that's all these service mesh products that you see today use proxies of some kind, right? An API gateway is a proxy, right? So you'll see those types of capabilities, arrive in those proxies, right? Most of what most API gateways do today is routing, and Envoy is a very, very capable router, right? So what we do could be considered, pretty much equivalent to that, right? The thing that you see in API gateway products that we don't do a lot of today is content transformation. Mm-hmm. But if you went to EnvoyCon this week, you would have seen them talking about some content transformation-like features, right? And getting those things into the data plane. So I think it's a blurry distinction. It's one that we mostly don't care about, and what we care about is just making sure that we can put that functionality into the places on the workloads that need to be talked to or talked from, right? Whether it's VM, mainframe, pod, container, function, right? It doesn't really matter.
So I think we need to draw the distinction between where the code runs, which is what you're explaining about Kubernetes containers, VMs, or whatnot, and also having the code that you run your application calling external services, which is a use case that we're seeing, of course, very often. And the advantage of working with a service mesh is that all of the calls can go out through an egress gateway. And that egress gateway can be a central point that you're using in order to manage policies, access control, compliance, security, and so on. So that's a very common use case that we're seeing for external service calls.
The other thing I would add is I think service meshes represent a change in architecture, right? I mean, API management traditionally has been an edge architecture where you do all of that management on an API gateway on the entry into some environment. And what we're finding, of course, is that the same kinds of things you want to do on the edge, you want to do between applications and between services and between teams. And so you want that same capability pushed into a mesh architecture, not an edge architecture. And there's some interesting integrations happening. I know on our side at IBM, and I think you guys are doing some similar things, we're taking some of our API management where you have concepts like API keys, right? And classification of user access to APIs through API keys, and using extensibility in frameworks like Istio to allow the mesh to understand the keys and make decisions about where to route. And that's not a concept that's inherent in Istio today, like this API key thing, but it's inherent in API management, and we can bring the two together and allow them to kind of blend in some interesting ways.
Yeah.
Right.
And by similar note, I expect that we'll see APM vendors start to integrate with various control planes to be able to affect the same policy behavior, but have their API management functionality.
Yeah, exactly. Right here.
You talked a little bit about the maturity of Linkerd and Istio where it stands right now, but I'm curious, I mean, you're solving kind of the same subset of problems, broadly speaking. Is there a philosophical difference in which each project is headed, or your approach to how you're handling the service mesh?
Yeah, I'll speak to the Linkerd philosophy, and then someone else can speak to the Istio philosophy, because I think you're right in that the goals or the value props are the same for these projects as well as the 50 other service mesh projects that are out there, but the implementations are very different. I think that. Yeah, it's due to a very different kind of design philosophy. So for Linkerd, this kind of relates to what's happened to us, in this transformation from 1.x to 2.x. We care very much about the operational surface area of Linkerd. Like, we are asking you to install this thing on your cluster, and you're going to have to wake up for it, and you're going to have to, debug it at 3 a.m. when things go wrong, although things never go wrong. And so that kind of gates not gates, that shapes the sorts of features and the way that we introduce features to Linkerd. And I think for us, like, the goal is, there's kind of two audiences. The first audience is, well, who's actually adopting Linkerd? Well, it's kind of this platform owner audience of, the people who are the same folks who are adopting Kubernetes and adopting Docker, and sometimes that's easy and sometimes that's difficult. But then there's this other audience of the people who they are serving, which are the developers or the service owners within their organization. And we believe strongly, at least for Linkerd, we believe strongly that we have to serve both audiences. And you kind of have to, you got to satisfy the first folks, because they're who are actually going to implement the service mesh. But then you also have to satisfy who, we're not just doing this infrastructure in a vacuum, right? We're not doing infrastructure for infrastructure's sake, I hope. We're doing it in order to make the lives of developers easier so they don't have to worry about all this stuff. And so that's a very important, if kind of one step removed, stakeholder. And so I think a lot of Linkerd's focus, like Zach mentioned, on debugging and diagnostics and that sort of stuff, is really informed by our desire to help developers, who are deploying stuff, with the service mesh, actually understand what's happening in their lives. Also, there's a selfish interest there, which is that whenever you install a service mesh for the next 6 months or 12 months or 18 months, the thing that always gets blamed whenever anything goes wrong is a service mesh. So we are very incentivized to have lots of diagnostics in there so that we can defend ourselves, because otherwise we end up in these very irritating conversations. And it turns out that it's DNS the whole time. It's always DNS.
I think, the initial goal with Istio was to kind of provide this existential proof that you could do this, right? That you could reliably provide all the features of a service mesh, that you could roll it out at large scale, that you could show the end-to-end security model, right? And you could show how you could define centralized policy and basically tell an end-to-end story that, while that end-to-end story is probably something that would take an enterprise 3 years to adopt, you kind of have to show people that it exists before they're willing to actually go and take it on board. So that was, you got to walk before you can run. Now having done a bunch of that, our primary focus is on quality, scale, and integration, right? And because of the customers that I talk to, and I think, IBM and other companies that we partner with in this space, it's a lot about environmental integration. It's a lot about reach, because, okay, I want to do mesh, but I've only adopted Kubernetes for 15% of my workload. Mm-hmm. Right? So the security team is bought into the notions, but it's not useful to me unless I can roll it out everywhere. Right? So, coverage is a big deal. We get a lot of asks, a lot of pressure around that. So that's been a strong focus for us. And that has also driven some architectural changes in the product around componentization to make that environmental coverage easier. So that is the focus, probably has been the tactical focus since 1.0 shipped. Mm-hmm. We care about the things that William described, for sure. We work quite hard on those things, but in terms of kind of the architectural direction and what we've been trying to achieve, it's about extending the reach of the platform, right? Service mesh, not just for Kubernetes.
Right. Okay. Yeah. Question?
I have two questions. So we have a service A to service B, the communication going between them. Now we are adding a component in as a proxy, and there is an additional hop that comes from, there are two additional hops between them. talking about low latency calls, like 2 milliseconds or like even lower, is it going to affect such calls, or have we seen? That's one question. I have another question. I want to talk about connection pooling. Right now, we have util classes which has this list of connection pools between, and so it becomes faster. Like the load is faster. How is that handled in the service mesh architecture in general? So those.
Yeah, I can speak a little bit to that. So first, the way that, like Louis mentioned, the way that pretty much every service mesh works is by inserting these proxies, and there is a cost to doing that, right? In the olden days, we'd have these fat client libraries, and there'd be no cost to, well, much smaller cost, I guess, to calling them. But the reason we've done that is because it gives us these operational conveniences, and it's kind of, it's fit in nicely with the rise of Kubernetes and the ability to, and containerization, where now like it's the deploy kind of headache that comes with doing that we would have had 10 years ago is now a lot easier. So there's always a trade-off. If you have these incredibly low latency requirements, then you may not have a service mesh that is satisfactory, simply because of that. On the other hand, some of the kind of fancier things that the service mesh can provide may be able to speed things up in the long run. So by having intelligence in the way that the requests are load balanced across things, by being intelligent about connection pooling and things like that, sometimes you can actually speed things up even though you're adding more proxies. And I think we had a blog post about the benefits of moving away from round robin request balancing. But once you get down to, I guess my sense is once you get down to kind of the single-digit millisecond stuff, then it gets a little dicey. Of course, Linkerd's proxies are incredibly fast, and we have a P99 of less than 1 millisecond, thanks to all this amazing engineering that we do. But you're still incurring a hop.
Yeah, I mean, I think, just to echo what William said, we've run into situations, particularly, one of the advantages of service meshes is you get a kind of more uniform network behavior, regardless of what the application was built with, when it was built, and it might have been built 7 years ago. We've certainly seen cases in production where people have things go quite a bit faster because they were using, let's say, HTTP 1.0 without connection keep alive, right? And that is just really bad from a network performance standpoint. So, for the brown or the brownfield things, and some of that's not even that old, right? You actually tend to go faster.
Yeah.
We obviously have a lot of experience with this at Google because we actually use sidecar proxies in the data plane at scale in Google. We don't use Envoy, but we use something very much like it. And we've talked before a bit about the performance of, or what we think we can achieve with Envoy, which would match what we've done internally at Google. And now you're talking in the low hundreds of microseconds of overhead per hop, right? As long as you use the proxy the right way, talk to it the right way, that's eventually what we should all roughly be striving for. That's not to say that it's not a hop, it's still a hop. And there are interesting efforts going on in the ecosystem around squeezing those hops down. You go talk to the Cilium guys and the work that they've done in the Linux kernel to kind of just make local host IP super, super fast, right? Even faster than Unix domain socket. Yeah. Right? So you can squeeze tens of microseconds out of those hops. So cool. At some point, right, it's going to be really hard to measure the difference between those two things.
Yeah. The other, a little bit more future-looking, one of the things that I think that we'll see as the service mesh control plane matures and we kind of standardize on APIs for configuring data plane is that you'll see heterogeneous data planes for different use cases. Because a lot of line of business Java apps have SLOs, of a second or more. And a couple of milliseconds here and there in the proxies really aren't important. And so maybe I want a more featureful proxy like Linkerd or like Envoy. Maybe I'm doing something really high performance, but I still need some of the, I still want the load balancing architecture without extra hops through the network that a middle proxy gives me, or I want some limited amount of visibility. And so you reach for some simpler implementation. You could imagine in the future something like, some P4 implementation that gives you low-level fast things for those specific use cases where it really, really matters. Now, I think we're a pretty long way away from that today, but I do think that that's where we're going to head as we mature. And I think one of the big blockers for that is standard data plane APIs.
Yeah, I mean, you'll see things like Envoy as user space IP stack.
Yep.
You know, at Google, we're doing work to make those APIs, the control plane APIs, work with gRPC directly, right, without requiring a proxy, right, for a limited subset of the features. So if you're really performance sensitive, you can kind of mix and match between those two things. So you're just going to see a lot of kind of innovation in that space, I think.
Yeah.
And there's lots of companies downstairs talking about it. Go talk to the FDIO guys. Like there's a ton of stuff.
Yeah.
All right, one more. Oh, I'm gonna be nice. I know. Hold on. There's lots of people.
Thank you. Today in my company, we are handling this security, observability, and control with libraries. And it's easy to explain the advantage of going to a standard service mesh. But these guys, they are now looking at doing more asynchronous communication with Akka framework using Kafka. So the question is, what is the position of service mesh in that area? And kind of sub-question is that I would like not to see back a central Kafka broker or something like that. So are you really thinking about taking asynchronous communication, keeping the mesh structure of a service mesh?
I think this is a really interesting question, and I think it's an area that we're working on, which is how to extend Istio to support multiple different protocols, and what does it mean when you have asynchronous communication, where are you going to get the value from Istio? And you know, there are several areas. Visibility is one of them. Policy is another one. So I think this is an active area of research for the future. Definitely.
No. So this is a pretty early space, right? I mean, we're still trying to get people happy with HTTP and gRPC and the synchronous protocols. Like Akka, like I know the Akka stuff pretty well. It's pretty impressive engineering. I think when you talk about asynchrony, one of the more interesting things to discuss is what effect does that have on the security model, right? Where job A emits message into broker, and then it spits back out somewhere at job C. Right. How does job C know that it came from job A?
Yeah. And to be clear, that's the fundamental challenge with event in the architecture that Istio and Linkerd both implement. That's the fundamental challenge, is it goes into a black box and they all mix and then they come out.
Right. So one of the things you really want to be thinking about when you talk about asynchronous is talking about message provenance, and the PKI infrastructure that we use with Spiffy should allow you to have strong provenance for messages as they transit through brokers, right? Even though it's not point-to-point between two different trust domains. Right? And I think that's probably the thing we should think about the most, right? And then routing and how fast we get that message there are almost, right? Like that's technology, we can make that go, right? There's plenty of stuff to make that go. Envoy will pick up support for things like Kafka as a routable protocol, but I worked on PubSub at Google for a little bit, so I have, right? People care a lot about message provenance, and I want to make sure that my message doesn't go to somebody who's not allowed to see it, right? So it's that both sides of those two things.
Great. One more?
What are the top priorities for Istio in 2019?
Performance, scale, environmental integration. Sorry?
All of it. So pilots should be able to serve more envoys. Pilots should be able to configure envoys faster. Envoys should be able to transfer data faster. Mixers should be able to compute policy faster across the board.
Yeah, also multi-cluster.
Multi-tenant? So in the 1.1 release, we're in the middle of making things have a much stronger namespace boundary in terms of administrative control. Yeah. So you'll see some changes in the APIs that align better with the kind of namespace as administrative boundary, which is an important feature for many, many people.
Yeah.
Well, great. Well, thank you first to all of you for participating, asking questions, for the panel, for randomly addressing anything. Thank you for coming.
Thanks, everyone.